So today we're going to talk about the reaction quotient. So this is when you have a system and it may or may not be at equilibrium. So Q, our reaction quotient, think, division quotient, has the exact same form as the equilibrium constant. It just may or may not involve equilibrium concentrations. And so then we'll compare the value of Q to the value of Kc and figure out, are we at equilibrium, or if not, which way are we going to go? So let's just jump in. So at a very high temperature, Kc equals 65 for the following reaction. If the following concentrations were detected, is the system at equilibrium? And if not, which direction must the reaction proceed for equilibrium to be established? So then we have our concentrations. So we're going to write our Kc expression. Okay. So if this is at equilibrium, we put in those values, we get 65. If we get something that's not 65, then we're not at equilibrium. So Q has the exact same version, the same setup, and we'll plug in all our values. So again, go ahead, use your calculator, type this in, make sure you can do this on your own, and you should get a value of about 38 for Q. Well, 38 is not equal to 65, so we're not at equilibrium. The question is, which way will the reaction proceed in order for equilibrium to be established? Okay, so Q is less than 65, which means if we want that to get up to 65, we need our products, our numerator, to increase and our denominator, our reactants, to decrease. So if we're going more this way, we're going to go to the right, then we're going to say that the reaction will proceed right, or that the forward reaction will predominate until Q equals Kc. And once those two are equal, then we're at equilibrium. All right, let's try another one. Oh, hey, by the way, there's always some answer there. But anyways, write the equilibrium constant expression for this reaction. So take a minute, write it, and check your work. Okay. At 527, Kc for this reaction is 5.1. If the concentrations of CO2 is 0.15 molar, hydrogen is 0.25 molar, concentration of water or steam is 0.42 molar, and carbon monoxide is 0.37 molar. Calculate the value of the reaction quotient Q and determine the direction the reaction will proceed to achieve equilibrium. So I'm going to put all those values in, and I get 0.24. So again, this 0.24 is less than 5.1. So we've got to have more product, less reactant, so it'll proceed right. So let's see a little bit more complex, perhaps, version of this. For the following reaction, the equilibrium constant is 49 at a certain temperature. If 0.4 moles each of A and B are placed in a 2-liter container at that temperature, what concentrations of all species are present at equilibrium? So our Kc expression is this. Okay. And we know that that's equal to 49. Well, I know that I have 0.4 moles of A and B in a 2-liter container, and I have no C or D. So I have 0. Well, here my value is 49, which means there's a lot of product. So, and by the way, 0.4 divided by 2, 0.2. So these are my initial concentrations. But I know I've got to form product. In fact, we've got to form a good bit of product in order for this to work. So, and I see that my ratios are 1 to 1 to 1 to 1. So I'm going to be losing some amount X from both A and B and gaining some amount X of C and D. And then I'm going to plug that into my equilibrium expression. So at this point, there's lots of different mathematical ways of solving this. I want you to pause the video and use your math muscles to solve. Okay, so really, seriously, do that. and then we'll talk about what answers you get. All right, so hopefully you solved it, and you probably got 2 values for x, okay, because it's a quadratic. Well, one of those is negative. We can't lose a negative amount. Also, we would want to make sure that x is less than 0.2 if you had 2 positive values, because we couldn't then have a negative amount of our reactant. So your value that you should have gotten should have been 0.025, okay, which means our concentrations, I switched those. Okay, so C and D should have concentrations of 0.025, and A and B should have concentrations of 0.2 minus 0.025, or 0.175. Okay, so switch the A and B parts. Okay, and here's your mastery check. This will be on Google Forms.